Hello everyone, okay, so in this video we are looking at the average value of a function. This is the final video in this integration series here. So what is the average value of a function? Well, it's just what it says in the tin. It's just what is, on average, the value of a function over a given range. What's the mean value of the function? What was the average function? Right? So the average value of a function is given by this formula here that's in your log tables. A equals 1 over b minus a, and the integral of b to a, and then the function f of x. So use this when you see the words like average, average rate of change, average value, etc. Sometimes in the exam, you are given the integrated function in the question when you were asked to find a value. So you could be asked to find the average value of a really rotten function like 1 over x plus 3. But if you look previously in the question, they actually probably gave you the integrated one there. So find the average value of the function 2x squared plus 3x minus 1 over the interval 1, 4. So that's a, that's b. So it is going to be 1 over 4 minus 1. The integral between 4 and 1 of 2x cubed all over 3 plus 3x squared all over 2 plus x. Right? So let's see what this is. I'm just going to rub this out here. So when you integrate that here between 4 and 1, you're going to get here 188 over 3 minus 7 over 6. And then when you multiply it by a third, you get 41 over 2. So the average value of this function was 41 over 2. And that's essentially what average value is. Let's do some exam questions here. The inflated ball is kicked into the air from a point 0 on the ground, taking O as the origin, and x and f of x approximately describes the path followed by the ball. F of x equals minus x squared plus 10x. Find the values of x when the ball hits the ground. So f of x is the height of the ball. So we're looking for when the height of the ball is 0. So we're looking for when f of x equals 0. Minus x squared plus 10x equals 0. I'm going to take an x here, and then I'm left with x minus 10. Nope. I'm left with minus x plus 10, and then I'm left with x equals 0, and then x is equal to 10. So at 0 seconds and 10 seconds, the ball is on the ground. That makes sense because at the start, the ball hasn't even been kicked to the air yet, and then after 10 seconds, it lands back down. Find the average height of the ball above the ground during this interval. Right? So I'm looking for 1 over, so between 10 and 0, so it'll be 10 minus 0. The integral between 10 and 0 of minus x squared plus 10x. So 1/10 integral between 10 and 0 of minus x cubed all over 3 plus 5x squared. That is going to be 1/10 times minus 10 cubed all over 3 plus 5 times 10 squared. And then for sub and 0, they will go to 0 anyway. Put them in my calculator. I get minus 10 cubed all over 3 plus 5 times 10 squared. Divide by 10. The answer here is going to be 50 over 3 meters. That is the average value there. Okay, let's look at this one at 2024. Sophia puts money into a savings account and leaves there for a number of years. The following expression, f of t, the amount of money in the account in euro after t years is given below. F of t equals 5,000 e to the power of 0.04t. So that's going to be a is going to be equal 0, b is going to be equal to 5 because I'm finding the first 5 years. That's my kind of interval there. So it's 1 over b minus a, so it'll be 5 minus 0. The integral between 5 and 0 of 5,000 e to the power of 0.04t. Divide now, so it'll be 1/5 times 50 be integral this 5,000 divided by 0.04 is 1 it's 125,000 e to the power of 0.04 t. Shove that in there now. We're gonna get so 125,123 e to the 0.04 times 5 minus 125,123 e to the power of 0.04 times 0. That's going to give me 27,675.34. And then remember, I have this 1/5 on the outside. Need to multiply that by 1/5. And then I am roughly going to get 5,535 euro. Perfect. Right, let's try this one. 2022 deferred. So the price of a different car X years after it was initially sold is given by blank. So 25,000 times 0.8 to the power of X, where P of X is the price in euros. The euros integration to work out the average price of this car over the first 10 years. So first 10 years, so it'd be 0 to 10. That's my interval. So A 0, 10 is B. So it's 1 over 10 minus 0 of 10 to 0, 25,000 times 0.8x. That's going to be 1/10 of 25,000. 0.8x to the power of x will be 0.8x to the power of 0.8 to the power of x over ln of 0.8. Right, so there is my function there. And then if I evaluate that at these points here, the 1/10 times 25,000 times 0.8 to the power of 10 all over ln of 0.8 minus 25,000 times 0.8 to the power of 0 all over ln 0.8. I am going to get here 1/10, so 25, 1, 2, 3. 0.8 to the power of 10 all over ln minus 25,000 times 0.8 power of 0 all over ln to the power of 0.8. So I'm roughly going to get here 1/10 of 100,005.7825 divided by 10. So it says correct to the nearest euro. That's going to be 10,001 euro corrected to the nearest euro. Right, let's look at the next one here. 2 more left. 2018. So let h of x equals cosine 2x. Find the average value of h of x over the interval 0 to pi over 4. Give your answer in terms of pi. So it's the integral. The average value is to be 1 over pi over 4 minus 0 between pi over 4 and 0 of cosine 2x. That is going to be 1 over pi over 4. Integral of pi over 4, 0. Cosine 2x goes to minus sine 2. Nope. That goes to sine 2x divided by 2. sub that in. So that's 1 over pi over 4. Going to be sine 2 times pi over 4 is pi over 2, all over 0, minus sine of 2 times 0, which is 0, all over 2. So that is going to be sine of pi over 2. There's my 2 here. Minus sine of 0 over 2. So remember, we're doing radians. So my answer here is going to be 1 pi over 4 times this in here, the bracket is going to be equal to a half. So it says give your answer in terms of pi. So this would be pi over 4 times, nope. This would be 4 over pi times a half, which is just going to be 2 over pi. That's my answer there. And finally, the last one here, 2015. 2015, the approximate length of the day in Galway measured in hours from sunrise to sunset is calculated. It's calculated using this function 12.25 plus 4.75 sine of 2 pi over 365t. Use integration, find the average length of day over the 6 months. So where t is the number of days, so it's 184 days. So I'm integrating this between 0 and 184. 12.25 plus 4.75 sine times 2 pi over 365t. Oh gosh, this is going to be 12.25t plus 4.75. Well, it's going to be minus now, it's going to be minus cosine. So minus 4.75 cosine 2 pi over 365t all over 2 pi divided by 365. And I am now evaluating that in my calculator between 184 and 0. But I also have to find the average value, so that's just 1 over 184 minus 0. So I have to multiply all this then by 1 over 184. Do 1 over 184 times what I'm going to get here. If I sub in 184, I am going to get right. If I sub in 184 and then subtract when I sub in 0, I should get in here then 2805.77736. Then divided by 184, I should get then my average value to be 15.25, which is roughly minutes or hours. Was asked me to give my resultant hours in minutes, so it's 15 minutes and then a quarter of an hour. So say 15 hours and 15 minutes. Right, that one's a bit of a doozy. So that's an example there that would benefit from like your function on your calculator. So if I were to type it in here, define my function, put that nasty function we got there. 12.25 t, so we're going to say x. Minus 4.75 cosine of 2 pi over 365 times t x. Close the bracket. All over 2 pi over 365. So I defined my function there, and now I can sub in, well, I'm integrating between 184 and 0. So there you go, I get 280, but then I need to multiply that by my 1 over 84. 184. And then I get 15.25. That's how you can do it there on the calculator using your. Right. I hope this video was some help to you guys in that integration. I'll catch you guys later. Bye.